Hello, my name is Marissa and I'm the team lead for SAE Supermileage. The Women in Engineering program at Texas A&M University supports a team of undergraduate students to develop and construct a single-person fuel-efficient vehicle to compete at the SAE Supermileage competition. The Women in Engineering program supports over 4,500 undergraduate and graduate women a year, and Texas A&M University has the highest incoming class of freshman women in the country for the past 5 years. The SAE Supermileage competition is usually split into 3 categories: a technical inspection, performance on the track, and design report and presentation. The technical inspection is where the team's vehicle is tested against the rulebook to ensure that all safety precautions are met and the vehicle will run on the track without severe failure and injury to the driver. Overall performance on the track is based on fuel efficiency, and teams are given less than 1 liter of fuel and must run 9 laps around a track in order to calculate the efficiency in miles per gallon. In order to make this possible, we will strive to make our vehicles as light as possible and our engine's fuel consumption as small as possible in order to obtain the highest efficiency overall. Due to COVID-19 restrictions, we were unable to finish our vehicle last year in order to compete at the 2020 SAE Supermileage competition. This year, we will be competing virtually, meaning that we will only be participating in the design report and presentation competition categories. The design report and presentation allows team members to expand their communication skills and gain comfort in front of industry professionals. Unlike most engineering teams at Texas A&M, SAE Supermileage has rolling applications throughout the year and no previous experience is required to join because our largest goal as a team is to educate and support our members. We look for members that are motivated to learn and want to provide leadership and technical opportunities to women in engineering. In the past, we have held welding workshops, but this year we have new members attend weekly virtual lessons to learn basic automotive design and SolidWorks, and then complete weekly homework assignments that require individual research. As soon as members are comfortable with research in automotive design, they are able to work directly on the project. Our main engineering design goals are updating the chassis and completing engine modifications, which will be covered by our sub-team leads, starting with Myra.
Thank you, Marissa. As for the chassis design for our team, we have 3 main objectives: for the chassis to be lightweight, durable, and result in the least possible drag coefficient. The chassis follows a space frame design with moderate amount of triangulation. Triangulation of this chassis will basically ensure corner rigidity, as the chassis structure cannot be forced out of shape. In addition, it also prevents any sag in the beams due to high moment from the weights of either the engine or the driver. So it would be easier and it would result in long-term durability. The triangulation is supposed to be carried out at larger angles for our team, simply for the ease of welding procedures, and the chassis will be made using chromoly and is meant to be designed around the driver's dimensions. This would enable the team to cut as much weight as possible and ensure the safety of the driver cabin. Taking into consideration the safety aspect, the roll hoop is designed to be slightly higher in comparison to the previous models. Furthermore, the chassis shape is inspired by the shape of a raindrop. So this would ensure enough space for the engine and powertrain placement and will allow the vehicle to obtain a very low drag coefficient. Rather than curve the beams, the raindrop shape is obtained using various trapezoidal configurations, and plastic panels will smooth the exterior. In conclusion, the chassis design is inspired by naturally aerodynamic shapes with emphasis on a simple but structurally durable and efficient design. Moving on to our testing phase. For this semester, we chose to conduct the box torsion test in order to, first of all, test if the triangulation would improve any strength. Secondly, to test how the weight of the engines will affect the beams. Thirdly, to calculate the beam deflection and recognize the critical joints that we need to work on. And fourthly, to compare the accuracy of SolidWorks. So after conducting this design, we came to a conclusion that triangulation has in fact improved rigidity by a great factor, And we tried to simulate on SolidWorks a force of 30 newtons, and as you can see, it produced a deflection of 7.41 millimeters on the top beam, which is a very low deflection, and we hope it goes lower in the future semesters. I would now like to hand the presentation over to Zaira.
Thank you, Myra. So for the engine, the big modification we made this past year was adding an electric fuel injection. And due to COVID-19, the EFI installation was not completed last year. This year, we're finishing up the installation of the EFI onto our engine. And the EFI fuel injection is able to directly inject fuel into the engine. And some of the benefits of having EFI include having better fuel efficiency, consistent power, and it is also less maintenance than a carburetor. And because the competition is all about fuel efficiency, this modification is very relevant and important to this competition. For the future, we want to modify our engine more. Aside from the EFI that we installed this year, we haven't done other engine modifications. So for the future, we're looking into doing additional engine modifications, for example, modifying the overhead valve on the engine to improve the volumetric efficiency, and also it will create a more uniform ignition pattern. This modification will also increase the thermal efficiency of our vehicle. One of the challenges that we encountered when installing the EFI was that we had to reconfigure the fuel line in order to meet competition standards. For the fuel, this is the fuel line that we designed. This new fuel line now meets the competition standards. And this year, we're actually building this fuel line and setting it up. We've also created a more spacious chassis design to be able to accommodate for engine and fuel and the fuel line better than the previous year. Now, Esther will go over some more of our future goals.
Thank you, Sarah. This year, the reconstruction of the chassis became our biggest priority. To avoid a faulty frame, support beams at joints were implemented in the design. Analysis tests have been rendered on the chassis to examine its strength. The stronger frame will be able to endure its load, torsion, remodeled structure. There is more space comfortably. Along with these improvements, a fire extinguisher will be placed within the driver's reach in the event of an emergency with the engine. To ensure constant communication with the team, an interface will be installed in the driver's helmet. The team seeks to design the shell with lighter materials over the years and finally include the carbon fiber shell or a hybrid shell. The team aspires to build a, dy- dy- a dynamometer for better testing for the coming years and design a laser timer for better precision during the testing phase. As the team progresses through this year's competition, we will continue researching, designing, and reviewing our designs with industry professionals so that next year members will be able to manufacture the vehicle. We will also continue learning about automobiles and engineering design through lessons and workshops and through the year and participate in virtual socials to increase member retention. Thank you for listening. That concludes our presentation.